Hello all. Hello all. Today we will study about the preformulation. The name itself giving you the idea what is exactly the preformulation. That is something which is prior to the formulation, that is a preformulation. So after completion of this topic, student will able to understand the concept of preformulation studies. Along with that, they will also understand the various aspects of preformulation. That is how we can perform the preformulation, and students will get the clear idea about the role of preformulation in the formulation development to produce, to develop a stable, safe and effective dosage form. Okay, so before starting the pre-formulation, we should know about the drug discovery and development process through which we can know that at which level we can do the pre-formulation studies. So basically, drug can be discovered by the organic synthesis, molecular modification, or by doing some isolation of the plants. And when you come to know that this chemical entity is having some pharmacological action, the preclinical studies will be conducted to ensure its pharmacological action, its ADME, absorption, distribution, metabolism and elimination studies, and toxicological studies. And when it has confirmed that the drug is having less toxicity and strong pharmacological activity, at this stage we can develop a formulation. But before the actual formulation development, we should do the pre-formulation. If we have not performed the pre-formulation, then what happens? If we are not studied the physicochemical properties of the drug, then it may cause the problems during the actual formulation development, because we are not having sufficient information related to the API, related to the excipient and its compatibilities at the time of formulation development. And hence it will result in loss of wastage of the material, lots of wastage of the time. Okay, so to avoid all these things, if we are already knowing the properties of physicochemical properties of the API, then definitely it will help to develop a stable and effective dosage form. So this is actually the pre-formulation. So what is pre-formulation? It involves the study of physicochemical properties of the new compound, which could affect on the drug performance and which helps to develop a stable, safe and effective dosage form. And after doing pre-formulation, it confirms that there is no any significant barrier to the drug development process, to the formulation development process. We can proceed easily. Okay, so we have already studied at which level, at which time we need to do pre-formulation. Also, what is exactly the pre-formulation? Now it's time to know about how we can do the pre-formulation, that is aspects of pre-formulation. Pre-formulation can be done with the help of three aspects. That is a bulk characterization, in which we will study about the bulk properties of the API. The second aspect is a solubility analysis, in which involves ionization constant, the pH solubility profile, common ion effect, thermal effect, solubilization, partition coefficient and dissolution properties. And the third aspect of preformulation is the stability analysis, which involves the stability and toxicology in a formulation, solution state stability and solid state stability. Along with that, the drug excipient compatibility study. So the first aspect of preformulation, that is bulk characterization, and in which we will study about the crystallinity. In this video, we will understand about the bulk properties during the study of bulk properties during the preformulation, the crystallinity. So in this slide, you can see the various shapes of the crystal, various types of the crystal, which is known as a crystal habit. So crystal habit is the outer structure of the crystal, and the internal structure means the arrangement of molecules within the solid. Okay, the terms you should know, that is a crystal habit and the internal structure, which is known as habit is the outer structure of the crystal, and the arrangement of molecule within the solid is the internal structure. Crystal habit or its internal structure of the drug may affect on the some physicochemical properties of the drug, such as its flow ability, its hygroscopicity, that is a moisture content ability, and chemical stability. So it's important to know that which form of crystal we are using during the actual formulation development, because as we know that it affects on the flowability, hygroscopicity, and chemical stability of the API. So this is the classification of the compound, internal structure of the compound, which is a crystalline form and amorphous form. Crystalline form is again divided into single entity and molecular adducts. These molecular adducts are again classified into non-stoichiometric compounds and stoichiometric solvates or hydrates. If the inclusion compound is water, then it is known as hydrate. And the non-stoichiometric compound is divided into channels and layers. So this slide will explain you about the crystallinity and how it will affect on the drug development process. Okay, if you are using amorphous form of the crystal, so it will show you the high solubility, high dissolution rate, but this form is thermodynamically unstable because as it is having less particle size but having more surface area, and because of this more surface area, the chances of absorption of the moisture is more, and hence the form become a thermodynamically unstable. The second is a non-stoichiometric adduct, which is in which the solvent molecule entrapment within a crystal lattice should be avoided for the development because it is having low reproducibility. If we are using stoichiometric adducts, the conversion of anhydrous compound to hydrate within the dosage form may reduce the dissolution rate and extent of the drug absorption. So we'll study one video which will explain you about the concept of polymorphism and crystallization. Okay. So I hope you have understood about the polymorphism with this video. So polymorphism is the ability of a compound to crystallize in a more than one form with a different internal structure. So polymorphism also affect on the solubility and chemical stability of the drug molecule, and which have a big impact on a bioavailability and the drug development process. So during reformulation, it is important to identify the polymorph which is stable at room temperature and determine whether the polymorphic conditions are possible within the temperature range used for the stability studies and processing. Okay, so in this video, we will only study about the crystallinity and polymorphism. The next parameters we'll study in a next video. Thank you.